The question is now to determine if this function fx is differentiable at x equal to 2 at that point there. Because if you draw x minus 2 or the absolute value of x minus 2, this is the graph you get. Now just looking at it graphically, we can see that while it's continuous at x equal to 2, you can definitely see that graph. There's no hole in the graph, but it's not differentiable because the gradient of this function is negative to the left and positive to the right, and also totally different, and therefore graphically we can see it's not it's not differentiable at x equal to 2. But now our question would be to determine it algebraically. Now just a short revision on absolute values. Okay, this is fx and this is the absolute value of x minus 2. First of all, this remember, absolute value must always give you a positive, so this must always give you a positive value. Now if x minus 2, whatever you, if x minus 2 is positive, then it will look like this, because you don't need to change anything to x minus 2 if this value always gives you a positive. Now we know it will always give you a positive when x is greater or equal to 2, because if it's 2, it's 2 minus 2 is 0 and 3 minus 2 is 1, so it will always give you a positive. But let's say x minus 2 is a negative number, then you need to multiply it with a negative. That's why we get negative x minus 2, and that is negative x plus 2, and that's how you get that thing there, minus x plus 2, and that will always then give you a positive for all the x values less than 2. So for example, if you put in 1 there, it's negative 1 plus 2, and that will give you positive values because fx must always be positive. Now, so obviously we can see it's continuous. So continuous is the first to be continuous is the first criteria or requirement for it to be differentiable. But now the next requirement is that the function's gradient is the same to the left and to the right at the point where you want to determine if it's differentiable. Okay, so let's differentiate fx. Now if we differentiate that, it's just 1, because you know if you differentiate a constant it becomes 0, and to differentiate x, well, you take the 1 to the front and you minus a 1 at the exponent, so it's 1, and it's x to the power of 0, so x to anything to the power of 0 is 1, so you'll have 1 times 1, so it's 1. So so it will be 1. The gradient will be 1 for x greater or equal to 2, and if you differentiate that, then it will be negative 1. So you can straight away see the gradient is 1 just left to 2, and negative 1 just right to 2, and therefore it's not differentiable. So you can write it like this. You can say, well, the limit, I'll just shift this a bit down so that you can see it a bit clearer. So if the limit of x as x tends or approaches 2 from the negative side of well, this differentiated function, it's not equal to the limit of x as x approaches 2 from the positive side of the differentiated function, because this one is obviously from the negative side, it's negative 1, this is it's 1, so therefore it's not differentiable, because the gradient just left of the point and the gradient of just right of the point is not equal to each other.